Okay, 5.61, inverse of a function. Okay, the inverse function of f, denoted by f inverse. It looks like f to the -1, but when we see a letter with an exponent of -1, it means inverse. So f inverse is a function that if f of a equals b, then f inverse of b equals a for all values in the domain. Okay, so what they're really doing, if f of a equals b, then for the f function, x is the input, and then the b is the output. For the inverse, the opposite of true is true. So now the b is the input, and the a is the output. So the x's and y's are switching. Inverses are useful in the future, but for now we're just playing with them so we can get used to them. We'll find their value in a later course. Okay, so for the most basic type of function, let f be defined by the set 1, 3, 2, 5, and 8, 10. It's just a list of ordered pairs. F inverse is just going to be flipping the x's and the y's. So this is x, and then this is y. So for the inverse, when the input is 3, the output is 1. I'm just switching the x's and the y's. Okay, so for the next one, since the y is 5, now the x is 5, the y is 2. Okay, and then for the last one, same. I'm going to switch the x and the y. So now the x is 10 and the y is 8. Okay, we can have f represented by the table, and we do the same thing. For this table of f of x, if I do f of -1, I get 3. For the inverse, if I do f inverse of 3, I get -1 as the output. So if f of 0 is 5, then f inverse of 5 is 0. And then if f of 4 is -7, then f inverse of -7 is 4. And then for the last one, same, I'll switch the x and y. Instead of 2, 8, it's 8, 2. Okay, now let's consider the graphs of f and f prime. Okay, so for 3a, f of x is 2x minus 3. This is the graph of 2x minus 3. The y-intercept is -3. It goes up 2 over 1. A few dots are labeled. We're going to use them to graph the inverse. Okay, so this is the graph of f. Okay, for f inverse, I want to switch the x and the y. So one way is to switch the ordered pairs. Where should I start? Let me start down here. This ordered pair is 0, -3. Now, if I switch the x and the y, then I get -3, 0. -3, 0 is over here. So on the inverse, -3, 0 will be on the graph. Let's do the next ordered pair. How about this one right here? This is 2, 1. If 2, 1 is on the graph of f, then 1, 2 is on the graph of f inverse. Okay, one more. What is this? This dot over here is 3, 3. If I switch 3, 3, I still get 3, 3. So that's going to go right there. So if I draw the line for this, I'm going to make it long. It's still a line. This is the graph of f inverse. Okay, let's do the same thing on the next one, and then we'll notice a relationship between the two graphs visually. Okay, so this is the graph of f of x equals the square root of x plus 3. It's a square root function, and it's move left 3. 2, 3, square root. So we could have graphed this on our own. Okay, I'm going to graph the inverse using the ordered pairs that are marked for me. Okay, so where does it start? It starts at -3, 0, which means the inverse starts at 0, -3. Okay, what's the next point? This is -2, 1. So if I go to 1, -2, and then what's this last point? So I have 1, 2, which means 2, 1 is also on my graph. Okay, so I'm going to go ahead and sketch the graph for this. It started at the blue point and went through the purple and the orange and then had an arrow. So for the inverse, it starts at the blue point, goes through the purple and the orange, and then it has an arrow. Okay, and then that is the graph of f inverse. Okay, now these two graphs visually are reflections of each other, but they're only over a very special line. Okay, so f and f inverse are symmetric across the line y equals x. Okay, I'm going to graph y equals x on this graph so you can see that that is actually true. Y equals x is a line. The y-intercept is 0. The slope is 1, 1. Okay, I'm going to make it a dashed line because it's not part of the graph, but it does help us see the symmetry. So dot, 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 dot. Okay, that's the line of y equals x. Okay. If I were to fold this graph along this line, this side and this side would match up, so they are symmetric across that line. Okay, I'm going to graph the same line on the next one so we can see that the same is true here. Y-intercept is 0, 0, up 1 over 1. I'm going to make it a dashed line because it's not part of the graph, but it does help us see the relationship. Okay, and the same is true. If I were to fold along this line here, this stuff over here would match up with this stuff over here. So visually, if that looks like they're matching up, then there normally are the inverses of each other. Okay, so let's get to an example now. Okay, graph the given functions on the same axes. Verify visually that they are inverses of each other. To verify visually their inverses, I'm going to graph this line and see if they look symmetric. But let's start by graphing each function. Okay, these are all lines. Okay, so f of x equals 2x minus 4. The y-intercept is -4. Slope up 2 over 1. Okay, I'm going to do an extra couple dots just to make it straighter. Let me go ahead and graph this. I'm going to make it long. I'm also going to label it. That's f. Okay, now let me graph f inverse. What's f inverse? The y-intercept is 2. My slope is up 1 over 2. I'm doing it a couple times, and they don't have to intersect. I just want the line to be straight so I can tell. Okay, this is f inverse. Okay, verify visually they are inverses of each other. So I'm going to graph the line y equals x and then see if they look like they're inverses. So y equals x, the y-intercept is 0, up 1 over 1. Okay, it goes right through those corners. Okay, and if I graph that line, it does look like that divides this into two symmetric halves, so I think I've graphed it correctly. Okay, let's try one other like that. Okay, let me graph G. The y-intercept is 2. The slope is -2/3. Maybe I'll go an extra couple points just to make it straight. Let me graph that. That is this line. And let me label that. That is the function g. I'm labeling it because it's two graphs on the same axes. Okay, let me graph g inverse. The y-intercept is 3. My slope is -3 over 2. I'm going to go down 3 over 2. And I might do it a couple times to make my line a little bit straighter. Okay, this is g inverse, supposedly. Okay, to check if they're symmetric, I'm going to draw the line y equals x, which is the line of symmetry, 0, 1, 1. Let me go back a couple. I'm making it dashed because it's not part of the graph, but it does help me look at it and then stare at it and see, does this look like it would match this if I folded it over that line? I think it would. Okay, go ahead, pause the video and then graph the next ones, and then draw your line of symmetry and then make sure they work. When you're ready, unpause and check your answers. Okay, let's go ahead and look at our graphs. Here's my h of x. My y-intercept was -3. I went up 1 over 1. For my h inverse, my y-intercept was +3 and I went up 1 over 1. And my line of symmetry is y equals x. And then if I look at it, this is symmetric with this. Let's look at D. J of x is this line. So my y-intercept was -2. I went up 1 over 3. Okay, for J inverse, it was my y-intercept was 6. My slope was +3, so I wanted to go up 3 over 1, but I ran out of room. So instead of going up 3 over 1, I went down 3, left 1, just so it would fit. Okay, drew my line. My axis of symmetry is y equals x. Okay, and it does look like this is symmetric with this. Okay, last example. We're going to find the inverse ourselves. In this case, I gave you the function and the inverse. In this case, we're going to find the inverse ourselves. Okay, here's how you find the inverse algebraically. Okay, define the inverse algebraically. First thing, you let f of x equals y if there's a function notation, so this part right here. I interchange the x and the y, and I solve for y, and that's going to be my inverse function. So let's try it. Okay, so step one, let f of x equal y. So I'm going to say y equals 2x minus 10. Okay, next I'm going to interchange the x and the y. That means where the x is, I'm going to change it to a y, and where the y is, I'm going to change it to an x. So I get x equals 2y minus 10. I literally just erased this and made it a y, erased this and made it an x. Okay, and now we're going to solve for y, our new y. So the new y is right here, so I want to isolate the y. So I'm going to add the 10 to the other side. I have, what do I have? X plus 10 equals 2y. I'm trying to isolate the y, so I'm going to divide by 2. Okay, now x divided by 2, I can write it as x over 2, or I could do 1 half x. 10 divided by 2 is 5. So I solved for y. I got y equals x over 2 plus 5. Now, once I solve for y, I need to think back to what I was actually solving for. I'm trying to find f inverse. Okay, so f inverse of x is x over 2 plus 5. Okay, go ahead, pause the video, try the next one doing the exact same steps. Unpause when you're ready to check. Okay, let's check our steps. So the first thing, I changed g of x to y equals. I interchanged the x and y, so where the y is I put an x, where the x is I put a y. Okay, and then I wanted to solve for my new y, so I minus the 10 over. I divided by negative 3, and I decided to make it negative x divided by 3 and then positive 10 over 3, although there are different ways to write that. Once I got to y equals, I'm done solving, but then I need to remember what am I trying to find. I'm trying to find g inverse, because this is g, so I renamed it g inverse of x equals negative x over 3 plus 10 over 3. Okay, let's do 2 more. These ones are going to have fraction coefficients, but the method's going to be the same. Okay, so I'm going to change it to y equals 1/3 x minus 4. Okay, to find the inverse, I interchange the x and y. So now it's going to be x equals 1/3 y minus 4. Okay, now I'm going to solve for y. And there are different ways to do it, but I'm going to add the 4 over. So x plus 4 equals 1/3 y. Okay, now I want to get rid of the 1/3. Okay, now one way to do it would be, since there's a 3 at the bottom, I'm going to times 3 on both sides. Okay, when you times 3 on this side, remember you're timesing 3 to the whole thing. Okay, how is this helpful? This is helpful because this 3 and this 3 are going to cancel. So I'm left with 1y or just y. Okay, on the left side, I need to actually distribute though. 3 times x is 3x. 3 times 4 is 12. Okay, so I solve for y equals 3x plus 12, but I'm actually trying to solve for the inverse of h. So this is h inverse of x is 3x plus 12. Then if I graphed it, I could verify. Okay, last one. Feel free to pause if you want to do it on your own. Okay, j of x equals, I'm going to make it y equals 3/4 x plus 7. Since it's an inverse, I'm going to interchange the x and y. So x equals 3/4 y plus 7. I want to solve for my new y, so let me minus the 7. So what is that? X minus 7 equals 3/4 y. Okay, now I want to solve for y. I need to cancel the 3 and the 4. You could multiply by 4/3, or you could just multiply by the denominator and worry about the 3 later. Either way is correct. I'll do it by just canceling the 3 first and then doing the 4 second, but if you do it differently, I should say cancel the 4 first, then the 3 later. Okay, so since the 4 is at the bottom, I'm going to times 4 on both sides. If I do it on the right, I have to do it on my left in parentheses. Okay, we do this so that this 4 cancels with this 4. Okay, now on the right side, I still have 3y. On the left side now, I'm going to distribute. Okay, and then since I didn't take care of the 3 yet, I have to divide everything by 3. You can do a big fraction or you can do a bunch of little fractions. Okay, so y equals 4 thirds x minus 28 over 3. Okay, I found y, but I'm actually trying to find the inverse of j. So this is j inverse of x is going to be 4 thirds x minus 28 over 3. And then that's my inverse function. And again, if I graphed it, I could verify that it looked about correct.